So section 15.5 is all about indicators, and indicators are a chemical that is used to detect the presence of acids and bases, and we can use these to determine pH. On page 715 is a list of a whole bunch of different indicators and their transition intervals. A transition interval is the pH at which they turn color. Now, we have used indicators for a very long time in chemistry. If you think back to the lab that we did on Friday where we had the digital pH meter and all that technology, that hasn't been around for that long, but these indicators have been present for thousands of years. There are very natural sources. Red cabbage is probably the most common one that we would think of today, where there are recipes on the internet if you're interested in making red cabbage indicators, and you can go around the house and determine what substances are acids and bases. If you just want something to do on a Saturday morning, then, go for it, try it. But other indicators are around here. Even tea is an indicator. I don't know if you ever had tea with lemon, that the tea turns a lot lighter color in the presence of your acidic lemons. Here's another particular indicator, and that is my goldenrod paper. And goldenrod paper is a natural indicator. Goldenrod is actually a weed you might see on the side of the road that is this color. And they use it to dye, bright yellow paper. But in the presence of a base, here I have some sodium hydroxide. That, look what happens. I put some of that on there. It turns that nice, deep red color in the presence of a base. If I were to put acid on it, it just kind of gets wet, and that's about it. So anyway, how does this help us? Well, in a traditional titration, unlike the one that we did on Friday in lab, that here I have sodium hydroxide in the burette, and I have acid, hydrochloric acid, in the beaker. And then I'll go ahead and I'll use phenolphthalein. That's probably the most common indicator that is still used today. And phenolphthalein is extremely handy because in the presence of an acid, it is obviously colorless. And the presence of a base, it's like a magenta pink. It's easy to see the transition interval when you go from colorless to pink. Some of these other ones are harder because if it goes from green to blue, it could be someone's opinion on when is it green and when is it blue. But phenolphthalein is really, really nice because you have a definite transition where you can see not pink and pink. So let's see what happens here. I'm going to put some of my base in here, and kind of zoom in. And there's that magenta pink, and I may have already put a little too much in here. So, look at it, it disappears. So, really, I am just a couple drops away from reaching my endpoint. Okay, one drop can make a difference between having your endpoint or not. So, obviously here, I still haven't reached my endpoint, but boy, I'm awfully close. I probably just went over right now. The idea for phenolphthalein is if the pink remains, let's say 3 seconds, that you've reached your endpoint. This deep magenta probably means I've gone over my endpoint, that I have actually too much base now in here. So probably what I'd have to do is maybe retitrate and keep my eye on the volume. And when I get a little bit closer to the endpoint, I would go drop by drop. So anyway, this is a good idea of how indicators work. Now there's another indicator that is actually quite useful, and that is universal indicator. And universal indicator is right here, and it is colorful throughout the whole process. So universal indicator is a red color in the presence of an acid, and it will go through the colors of the rainbow. I'll kind of turn this around. Goes through the colors of the rainbow, and while you add base. So in the presence of an acid, it is red. I don't know if you can tell, but we're kind of lightening up the red a little bit, and we are going into perhaps like an orangish phase. As we watch this happen. And actually, I kind of went through, and there it goes into the blue stage. So I went a little too fast. You couldn't see the orange, the yellow, the green. If I had slowed it down, you could have seen the whole color change. But now in the presence of a base, it's blue. And so universal is actually used quite a bit. And you can actually use like a key to determine what the pH is depending on the color. So that is my demo for indicators. So I'll be back at the smartboard. See you soon. Okay, I'm back at the smartboard, and before I begin, I would like to give a shout out to Danny Vanderbilt just because I want my day back. So this is actually Saturday, and he called you by your right name. So when we come back on Monday, we need to change that board from a 0 to a 1. Just want to add that. So anyway, you saw my demo on the indicators, and so here's our notes. Uh, Again, the indicators will tell you the equivalence point. I called it an endpoint when I was in the lab showing you the demo. They're the same thing. Equivalence point and endpoint, that is where your moles acid equals moles base. And if you know your volume, if you know your molarity of the base, you know your moles base, because of the equivalence point, you know your moles acid, you know your volume of acid, you can calculate your molarity of your acid. For that, you can also calculate pH. So anyway, how do you determine this? We found the pH meters from the lab on Friday. Again, like I said before, historically we didn't have pH meters, so they had to use indicators. So how indicators work, most of these indicators are indeed weak acids, and so in the presence of acids and the presence of base, they can go between the acidic form or the basic form in a sense. So the color change occurs when the proton is lost or gained. It depends on which indicator we're talking about. So using indicators, again, depending on which indicators you use, with the universal, we didn't see that sharp change in color, but with the phenolphthalein, we did. So like I tried to show you, it didn't work out as well as I'd hoped, that if I had the single drop of the phenolphthalein, it would have gone from colorless to that pink color. And so you can really tell the difference of where you hit that endpoint when you got to the transition interval. So the suitable indicators must be indicated or selected based on the equivalence point. As you know, if you have a strong acid, strong base, the equivalence point is where the pH equals 7. But as we saw when we did the math earlier, that if you have a weak acid, strong base, the equivalence point is actually higher than 7. So it's 8 something perhaps. And so you want to pick that indicator that will change colors roughly in that range of that where the equivalence point is, where moles acid equals moles base. So if you have a strong acid, strong base, there we go. You'll take indicators between pH 5 and pH 9 where they'll actually change colors. Phenolphthalein is actually a change between 8 and 10. And you may wonder, why can you use even phenolphthalein that is still colorless at pH of 7? Well, look at this graph right here. Do you notice that with like basically, with a single drop of your base, look what happens. Your pH changes so great. So you go from, let's say, a pH of 4 to a pH 11. So many indicators would actually turn color in that range. Methyl red would turn color in that range, and thymol blue would. The problem with methyl red and thymol blue is that you're going from red to yellow in one case and then yellow to blue in the other case. And again, that may be a difficult time or difficult color change to pinpoint where did that change actually occur. With phenolphthalein, it was colorless to pink. You can see that real quick. So what about over here? If I did have a weak acid, here's my equivalence point is actually higher than the pH of 7 with a strong acid, strong base. So you have to be a little more careful as to which indicator would work. So you're trying to find some with an interval around 9-ish, and phenolphthalein would probably work just fine again for this one. And because it was 8 to 10, thymol blue would be pretty a good one to pick too because of its transition interval. I'm not sure methyl red would, because the yellow is occurring around 6 or even less than 6, and you haven't reached the equivalence point. It's still before you went up to this vertical spot here. So again, if you're going to use an indicator, you need to be very careful as to which ones you pick. But today, with the technological advances and your digital pH meters, this is fairly obsolete anymore. The real world industry does not use indicator. It does use the digital. So that is our talk on indicators. You can go ahead and describe the process you'd undergo to pick an indicator for a titration. Think about it a little bit, and I promise you on Monday we will have a cool demo.